Okay, now let's get into a slightly more complicated problem. Let's look at this data set over here and two possible boundary lines. There's this one here and this one over here. And now I want you to think which one of these two looks better. So maybe some of you said the one on the left and some of you said the one on the right. In reality, there's no answer. In some cases, we'll prefer the one on the left, and in some cases, we'll prefer the one on the right. If it's a medical model, for example, we wouldn't want to make any mistakes, so we'd prefer the one on the right. But maybe in other cases, we'd prefer the one on the left because we're okay making some mistakes as long as we have a well-spaced boundary. So it depends a lot on the data and the problem that we're approaching, which means that we need some flexibility here. That flexibility is going to be provided by the C parameter. The C parameter is just a constant that attaches itself to the classification error. That means we multiply the classification error by the constant. So what happens is the following. If we have a very large C, then the error is mostly the classification error, so we're focusing more on correctly classifying our points than on finding a good margin. But if the C is very small, then the error is mostly a margin error, so we're focusing mostly on a large margin than on classifying the points correctly. So here's a cheat sheet for you to remember. A small C is going to give you a large margin and it may make some classification errors, whereas a large C will classify points very well, but the payoff will be that it may have a very small margin. And the C is a hyperparameter, and in order to tune it correctly, we'll have to use techniques such as grid search, etc.